Distance between 2 points in a coordinate system uses, not surprisingly, the Pythagorean Theorem. And we get something nasty and scary looking. I'm going to show you what it looks like. Does that scare you? Well, I'm going to explain to you where it all comes from so that you can go, oh, it's not really that scary. It's just got a lot of notation. So the distance between these 2 points, we don't have to draw a line between them, but it kind of makes it easier if we do. In fact, we're going to draw the right triangle that we see, or that can be drawn with the distance or the line between them as the hypotenuse. So here's the segment that joins the 2 points, which will become the hypotenuse of our right triangle. Here's the right triangle. Now, you could have drawn it on the other side, and that would have been fine too. So it doesn't really matter which one you go with. There's a right triangle there. So finding the distance between these 2 points is really just finding the length of the hypotenuse, or the segment that connects those two, which is the hypotenuse of the triangle. So if we were going to do it using the Pythagorean Theorem, we can tell that the top part of this is 1, 2, 3, 4, 5, 6, 7 units long, and then it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units high. So using the Pythagorean Theorem, c squared equals a squared plus b squared. Always write it down. That's one way of memorizing it and making sure that you get the right numbers in the right places. We're looking for the hypotenuse, c squared, and that equals 7 squared plus 12 squared. So the hypotenuse squared equals 49 plus 144, and c squared equals 193. So I know that's really close to 196, which is 14. So I know this is really close to like 13.8. Turns out to be 13.89, so we're going to go with C is approximately 13.9 units. Oh, and to show our work, we would want to square root both sides. Now I'm going to show you how we could get that using the ordered pairs. So let's use another color. The left ordered pair is negative 1, 2, 3, 4, and up 1, 2, 3, negative 4, 3. And then the right one is going right 3. Well, that's no good. I hate it when I have that same number, because then you can get confused. Well, we'll label them. And down 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 9. So 7, which is the length of the small side, or A, it's really just the difference between the two x values, between negative 4 and positive 3. You can see the distance between that is 7. So that's where this first part of the distance formula comes from. The difference in x's is going to be this a squared. Well, and of course the squared is outside of the parentheses there. So negative 4 minus 3, remember it's their difference, squared. And now we're going to keep the plus in the a squared plus b squared. And that is the difference in y values. So let's see, maybe I need another color green. From here down to here. And that's going to be, again, the difference in y values, which is 3 minus negative 9 squared. Now this is going to equal c squared. Well, you can see what they've done right away is they've square rooted both sides. And instead of calling it c, we're calling it d for distance. So the distance is going to equal the square root of negative 4 minus 3 squared plus 3 minus negative 9 squared. And you can see that the distance would be the square root of negative 7 squared plus 12 squared. And you can see already that it's becoming what we've already done. So just remember that if the distance formula seems scary because of all the notation, that x2 minus x1 is just really the difference in the x coordinates, which is equal to the a, and the difference in the y values is equal to the b. And of course we need to square them and add them together, and then we square root them. But yes, that's what what makes it look so scary. Let's try a new set of points. How about this point and this point? Pause the video and try it yourself. So what I'm going to do is I'm going to find the coordinates of each point. So the one on the left is -1, 2, 3, 4, 5, 6, 7, 8, -2. The one on the right is +1, 2, 3, 4, 5, 6, 7, 8, and up 1, 2, 3, 4, 5, 6, 7. Now it's helpful to label these, and it doesn't really matter which one you label which. On the left, I'm going to label this one x1, y1, and on the right, x2, y2. And now I'll just plug it into the formula. So distance equals the square root of 8 minus -8 squared plus 7 minus -2 squared. So the distance is going to equal 16 squared plus 9 squared. 16 squared is 256, so the square root of 256 plus 81. So now we're looking for the square root of 337. And I get 18.357, and it goes on from there. So if I'm going to round, it would be 18.4 units. And if I wanted to quickly look at the triangle, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Sure enough, this length is 16. And up 1, 2, 3, 4, 5, 6, 7, 8, 9, just like I thought. And then of course we're trying to find that hypotenuse, and this is a right triangle. Well, 9 squared plus 16 squared, and square root it, 18.4 units. Let's do one where we don't have the graph anymore, just me giving you two ordered pairs. All right, so here you go, -3, 2, and -11, -8. So go ahead and pause the video and try it. The first thing I'm going to do is label them. x1, y1, x2, y2, and write down the formula I'm going to be using. Distance equals the square root of the difference in x values squared. That'll give me side A, plus the difference in y values. That gives me side B squared. And then we're going to square root all that. X sub 2 is -11 minus x sub 1, -3 squared, plus y sub 2 is -8 minus y sub 1 is 2 squared. So minus a negative is plus a positive. Finding the difference there is -8 squared plus -10 squared. So that gives me the square root of 64 plus 100. So that equals the square root of 164. Now I recognize 164 as being really close to 169, so I'm going to estimate, before I even try it on my calculator, right under 13. So approximately, I don't know, 12.8 or 12.9. I'm going to go with 12.8 units and then check it on my calculator. And I get 12.806, so 12.8 units is a good answer.